Death. It's life's one certainty, an appointment none of us can reschedule. We spend our lives building, creating, and experiencing. But what happens when the show is over and the curtain falls on our physical selves? Our bodies, these vessels we've inhabited for a lifetime, embark on a fascinating, if slightly macabre, journey. It's a journey of transformation, a return to the basic elements that make up all life on Earth. This process, known as decomposition, might seem gruesome at first glance. We're conditioned to associate death with stillness, with an unchanging finality. However, death is far from static. It's a dynamic process, a flurry of activity on a microscopic level. Cells that once hummed with life begin to break down, releasing their contents into the environment. This decomposition process, while natural, might seem unsettling to some. Our culture, often uncomfortable with discussions of death, tends to shy away from the nitty-gritty details. But understanding death, in all its complexity, can be surprisingly life-affirming. It reminds us of our connection to the natural world, to the cyclical flow of energy and matter. So let's delve into the science of death, exploring the fascinating and often misunderstood process of decomposition. Prepare to be amazed by the intricate dance of biology, chemistry, and even physics that unfolds as our bodies make their final transformation. Death, it turns out, is not a single event, but a process. It's a cascade of changes that begin the moment the heart stops beating and the lungs cease to draw breath. These early post-mortem changes, while subtle, provide valuable clues for forensic investigators, helping them determine the time of death and reconstruct the events surrounding a person's passing.
One of the first noticeable changes is rigor mortis, the cooling of the body. Without the constant internal furnace of a beating heart, the body gradually loses heat to the surrounding environment. This cooling process, while influenced by factors like clothing and ambient temperature, follows a relatively predictable pattern, allowing forensic experts to estimate the time of death with reasonable accuracy. Next comes livor mortis, also known as lividity. Remember those purple splotches you sometimes see on your skin after sitting in an awkward position for too long? That's essentially livor mortis in action. After death, blood, no longer circulating, settles in the lower parts of the body due to gravity. This pooling of blood results in a purplish discoloration of the skin, providing clues about the body's position after death.
Finally, we have rigor mortis, the stiffening of the muscles. In life, muscles contract and relax due to a delicate balance of chemicals. After death, this balance is disrupted, causing muscles to lock in place. Rigor mortis typically sets in a few hours after death, peaks around 12 to 24 hours and gradually subsides over the next day or two.
These early post-mortem changes, rigor, livor, and rigor, might seem like macabre details, but they are essential tools for forensic investigators. By carefully analyzing these changes, investigators can piece together a timeline of events, providing valuable insights into the circumstances surrounding a death.
When we think about decomposition, bacteria play a starring role. These tiny organisms, invisible to the naked eye, are the unsung heroes of the decomposition process. They kickstart the breakdown of tissues, transforming complex organic materials into simpler substances that can be recycled back into the ecosystem.
Bacteria are everywhere, on our skin, in our guts, and in the environment. After death, the body's immune system shuts down, allowing these bacteria to proliferate unchecked. They begin to digest tissues from within, releasing enzymes that break down cell walls and liberate nutrients.
This bacterial activity generates gases which cause the body to bloat and emit odors. It's a natural part of the decomposition process, albeit one that's often unpleasant to witness or smell. But without bacteria, decomposition would be a much slower and less efficient process.
Different types of bacteria thrive at different stages of decomposition. Early on, anaerobic bacteria, which don't require oxygen, dominate. Later, as tissues break down and oxygen becomes more available, aerobic bacteria take over. This succession of bacterial communities ensures that decomposition proceeds smoothly and efficiently.
So, while bacteria might seem like a nuisance, they're actually crucial to the cycle of life and death. They help return our bodies to the earth, completing the circle of life and contributing to the fertility of the soil.
In a way, bacteria are nature's recyclers, breaking down the old to make way for the new. It's a reminder that even in death, life persists, and the cycle continues.
Understanding the role of bacteria in decomposition can deepen our appreciation for the intricate web of life. It shows us that every end is also a beginning, a chance for new life to emerge from the old.
All right, let's delve into the stages of decay. First, we have the fresh stage, which begins immediately after death. During this stage, the body starts to cool and rigor mortis sets in.
Following the fresh stage, we enter the bloat stage. Here, bacteria in the body produce gases, causing it to expand. This is often when the body becomes noticeable to insects.
Next up is the active decay stage. This is when the body starts to break down rapidly, and you'll see significant loss of mass due to the activity of maggots and other decomposers.
Finally, we have the advanced decay and dry remains stages. In advanced decay, most of the body's mass is gone, and in the dry remains stage, only bones and a bit of dried tissue are left.
Each of these stages provides valuable information to forensic scientists and can help determine the time since death.
There are several factors that influence the rate of decomposition. Temperature, for instance, plays a huge role. Warmer temperatures speed up the process, while colder temperatures slow it down.
Humidity is another key factor. High humidity levels can accelerate decomposition, whereas dry conditions can preserve the body for longer periods.
And let's not forget about the presence of insects. They can significantly hasten the decomposition process by breaking down tissues quickly.
Soil composition and burial depth also matter. Bodies buried in acidic soil decompose faster, and those buried deeper are less accessible to insects and scavengers.
All these factors combined can make each decomposition case unique, presenting both challenges and insights for forensic investigations.
Decomposition is a critical process in forensic science. It helps us determine the time of death, which can be crucial in criminal investigations.
Absolutely. By examining the stages of decomposition, forensic experts can gather vital clues that may lead to solving a case.
You know, there's a lot of myths about decomposition out there, like bodies turning to dust in a matter of days. That's just not true.
Indeed. In reality, decomposition is a complex process influenced by many factors, including temperature, humidity, and the presence of insects. Decomposition is a natural part of life. It reminds us of our shared fate and the cycle of life and death. It's a humbling process that connects us all. If you're interested in learning more about decomposition and forensic science, there are plenty of resources available. Books, documentaries, and online courses can provide a deeper understanding of this fascinating subject. Please like, share, and subscribe to this channel for very exciting information.